Exponential function is a function. Okay, you define like that. F of x is equal a to the x power. So my independent variable, que is x, now is located in the exponent position. This is different completely to the situation that you have in the power function. In the power function, okay, we studied before, power function is x to the m. Maybe n is 2, 3, 4, 5. This is the power function. No, this is exponential. It's completely different. And by the way, increasing faster. Now, the most important thing you need to know is that a is the base. It's an important parameter in the exponential function, the base. And we have two kinds of base. The base, well, the base is no arbitrary number. No. The base is always positive, and no 0 and no 1 because the k is trivial. It's possible to have negative base. It's possible. Then we have two situations. Situation number 1 is when the base is greater than 1, que is exponential growth. The growth. Exponential. It's exponential get increasing, no? Go up. Exponential growth exponential, and when the base is in between 0 and 1, it decay. We study both now. And the most important property. Let me start for the one example. F of x is equal 2 to the x. Wow. It's obvio que the base is 2. Si the base is 2, que es greater than 1, entonces es growth exponential. Okay? Let's do it the quickly evaluate this in different points. Suppose here x, y, and x comma y. And you evaluate into the formula que es 2 to the x power, no? Suppose 0, suppose 0. Entonces y is equal to the 0, que es 1. So you need to know, you need to remember that any number or expression raised to the 0 power, the answer is always 1. Therefore, the point is the point 0, 1. And this is important to understand that this point is universal, because regardless what is the base, CS2, CS3, CS4, CS, any number raised to the 0 power is always 1. Any exponential, any family of the exponential function passing through this point, 0, 1. I call this in my language universal point for exponential family, no? Okay, let's continue. Easy value, no complicated. 1, 2 to the 1 power is 2. And the point is 1, 2. 2, okay, bueno. 2 to the second power is 4. And the point is 2, 4. Okay. 3 is the same. 3 to the cubic power is 8. No? So, let's do it. I know. 3 is 2 to the third power, que is 8, and the point is 3, 8. Okay, now, not only positive value, negative value now. Negative 1. Negative 1 is 2 to the negative 1, who is 1/2. Remember, exponent negative means reciprocal. And the point is negative 1, 1/2. Negative 2 is similar. It's 2 to the minus 2 is 1 over 2 to the second power, que is 4. It's 1/4. It's negative 2, 1 over 4. And negative 3 is the same. 2 to the negative 3 is 1 over 8. No? Do you see the difference? When it's positive, it's in the top. When it's negative, it's in the bottom. It's reciprocal, no? Negative 3, 1 over 8. If you are doing the graph To understand much better this exponential, let's do a graph. Okay, let's do a graph by hand because I want to do slowed after we see in decimals. I prepared decimal for you. Okay, look, you plot the universal point, que es 0,1. Bang. 0,1, this guy. 1,2, this guy. 2,4, 2,4, this guy. And 3SA gets completely out the paper. No? And negative 1, negative 1 is 1/2. 1/2 is the midpoint between 0 and 1. Negative 1/2, I suppose, gets here. Negative 2 is 1/4, get half of the half is here. And negative 3 gets 1/8 is the half of the half of the half is here. As you see clear, this is the shape of the exponential function graph. It's important to understand this approach to the x-axis but never touch. Because this quantity is 1/8 or 1/16 or 1/32, so it's smaller and smaller but never 0. Therefore, it's important to understand that our exponential function have horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0, que represent the x-axis. Okay, just what is the most important property for that function that we study now? Property. Okay, property of the exponential. Okay, this is, I'm using one example, base 2, but it's common for the base 3, 4, 2.5. Any real number positive and greater than 1 is the same situation. Property. Property of exponential. Exponential growth, of course. Property of growth exponential. As always happens, when you study a new function, you need to determine domain and range. This is a super important property. Domain and range. It's obvious, looking at the graph, that our graph covers an x-axis, que es the domain. Domain is the set of the x value in which the function is defined. All real number, right? All real number. This is nice function. No point undefined. They are not point to be undefined. That is a reason that when you study today the exponential equations always have solutions. Okay, because the domain is all real number. The range, no, because I don't see any value of the exponential in the negative part, only positive part. And 0, no, because the curve approaches to the x-axis but never touch. Entonces, paréntesis, 0, infinity. Okay, it's important to understand this idea because suppose que in one moment of the chapter, we have that equation. 2 to the x equal negative 4. It's obvious that this equation has no solution because the exponential never is negative. Negative 4 is a line like that, no? And there are no intersect between the red curve, is our function, and the line y equal negative 4. No solution. Important is, this is just example to understand. Exponential function never give me negative value, always positive. That is a reason that the range is from 0 to infinity, and not include 0 because it's asymptotically. Okay, one more information. You know, this is obvious because that function is increasing function. Increasing function. Always going up. Okay. Remember the roller coasters, you travel from left to right. The roller coaster go over, always. It's increasing function. This is important characteristic because in decay happen completely the opposite idea. But okay. Now is the symmetry of that function is neither. So no even nor odd. It's neither. Because we have no any kind of symmetry. Symmetry with respect to the x-axis, no. Symmetry with respect to the y-axis, no. Symmetry with respect to the origin, no. So it's neither. A very important thing is we have horizontal asymptote. So any graph. So in this test, one question is, do the graph of the any exponential function. I don't know, see, in this case, I am doing the graph of the basis 2, no? But in the test, I put the base 3, or base 5, or base 7, or base 4.5. But any exponentials as part of the graph to do the horizontal asymptote at y equals 0. This is important part of the graph. Because you are doing the graph without asymptote, like that, whoa, and nothing here. So this is not complete. So you have no full credit, no, for this graph. Okay, the important thing is, this graph corresponds with the one-to-one function. One-to-one function. So our exponential is one-to-one function. What is important in this idea? Well, remember to verify if you one-to-one or no, you apply the famous horizontal line test. Sorry, horizontal, not vertical. Vertical, yes, past vertical and past horizontal. Therefore, the exponential function has inverse. We study maybe today, que es the logarithmic function. In your moment we study. Okay, it's invertible. The inverse exists. And finally, important, in my opinion, this is the most important part. What is the typical point? You plot at least 3 points in the graph by hand. One of the typical are the universal 0,1, comma 1, comma the base, que es 2 in this example, and -1, comma 1/2. Pero in general, for any example in the test, you plot the universal. You plot 1, comma a, because the base in our example is 2, pero si es 3, es 1,3, si es 5, 1,5, and -1, 1 over a, reciprocal, right? Entonces, suppose, to finish that part, suppose in the test, I ask you, do the graph of this exponential. Phi equal phi to the x. And you recognize, wow, the base is 5. And phi is greater than 1. Therefore, I expect exponential growth. Okay, this function is increasing. And I quickly plot the point. What point? Universal. Universal is this point. 0,1. One more. 1 and -1. I know that and 1 is 5. 2, 3, 4, 5. I plot that point, that by the way is 1,5. And this is -1, que es reciprocal of the base, que es 1/5. You divide this segment in 5 portions. I suppose that here, this point is the point -1, 1/5. And you are doing the graph of this exponential. Approximately that. And don't forget the important horizontal asymptote. Everyone follow me? This is the thing I want. Horizontal asymptote at y equals 0. Super good?
Yes.
Okay, now I want to change something. Suppose I have another example, okay, in which the base is less than 1, o sea, in between 0 and 1. Suppose this example. I move on to this. Suppose I want, because in the test it's surprise. I give you one exponential, entonces you need to identification si es exponential growth o exponential decay, ¿no? Suppose 1/2 raised to the x is also exponential, right? But I realize that the base is 1/2. 1/2 is less than 1, so we are in the decay exponential. And the graph is, you know, a little bit similar. Let's do it. Suppose I have an idea. Again, x, again, y equal 1/2 raised to the x power, and the point x comma 1, comma y. Again, the famous point. 0, bueno, es 1/2 raised to the 0 power is 1. I know that when you put the exponent 0, the answer is 1. The point is 0,1, again, expecting universal point. Suppose now 1, entonces 1/2 raised to the 1 is 1/2, it's obvious. And the point is 1,1/2. And 2 is 1/2 raised to the second power, que es 1/4. Entonces 2,1/4. Do you see in the same measure, okay, increasing x, the y decreasing? That's the reason, okay, the only difference in the property is that the function is now decreasing. That is the reason it's called a decay exponential. Okay, now let's see what happened in the negative. Suppose -1. Entonces 1/2 raised to the -1, oh, es 2. Why? I don't understand. 1/2 raised to the -1 is reciprocal. Reciprocal is flipped, 2/1 raised to the 1 power, no? That you change the sign of the exponent and flip it, the fraction. And this is just 2. So the point is -1, 2. And making sense because 2 is the reciprocal of the base, and the base is 1/2. And -2 is 1/2 raised to the -2 is 4. And the point is -2,4. Okay. Entonces, this is the moment to make a graph. You can, of course you can, but no. Why no? Because I need to analyze in another way. Look, using transformation idea. Okay, I know very well. Suppose that we have y equal 1/2 raised to the x power. But I know that 1/2 is equivalent to, say, 2 to the -1 raised to the x power. You see here, 1/2. Here, sorry. Okay. And you multiply the exponent. It's a property for the exponent. It's a rule of the exponent. It's 2 to the -x. Wow. Because I want to compare this formula and this formula. So this formula, look, and this formula. Oh, it's a transformation, but what kind? Remember, when you have a function and you replace x for -x, we have a reflection about with respect the y-axis. So the graphic of the exponential decay is exactly the same, but symmetric with respect the y-axis, this graph. Let me use another color. Well, maybe blue. We have the universal point again. This is a point passing through any exponential, regardless the base, regardless anything. Any exponential passes through this point. But this is completely symmetric. This point becomes this point, symmetric with respect to the y-axis. This point becomes this point. this point becoming this point, and this point becoming this point. So this is the graph. The blue and the asymptote is the same. The blue corresponded with the 1/2 raised to the x power. Tau to the x power. And the red is the graph of the 2 to the x. Super clear? And domain, look, the property, I don't want to repeat this again. The domain, same. Range, same. The behavior, no. Behavior is decreasing now. Remember the roller coaster? When you travel from left to right in the x-axis, the y is going down, decreasing. Symmetry, neither. Again, neither. Horizontal, yes, at the same point. And of course, the typical, this is the typical point to plot any exponential is given in the problem is universal, reciprocal, okay, universal. In this case, in the example that we are doing now, okay, the base is 1/2. You plot the universal, okay, no problem. Comma, 1, comma, 1, comma, the base, que es 1/2. Comma, -1, comma, reciprocal, 1/2, que 2. And you get the same point that we are doing in the table, no? Look in the table, I plot this guy. Is this guy. This is this. And this is this. You want to plot more? Okay, plot more, but 3 is enough. And don't forget, of course, in the graph to do the horizontal asymptote. We have no vertical, never in the exponential, no vertical, horizontal. Any questions so far? Everyone follow me? Anything that you need to clarify? Que it's confusing, exponential function, graph, property? No? Super clear. And we remember we have 2 kinds of exponential growth, exponential decay. Exponential decay is when the base is less than 1. No, exactly. It's in between 0 and 1, no? And do not include 0 and 1. 0 and 1 are illegal values. And exponential, suppose you have this example. Suppose que in the test I put to confuse you, y equal 4/5 raised to the x power, and y equal 5/4 raised to the x power, and you classify what is this, the first one, number 1, number 2, number 1 and number 2. Number 1 is exponential decay or exponential growth. Number 2 is exponential decay or exponential growth. Come on, answer me. Hey, what happened? Are you sleeping? Exponential decay or exponential growth? 4/5. Huh?
Decay.
Decay. The first one. How do you know? What is the reason? Because
It's less than 1, and it's between
the
0
base
and 0.
is less than 1. And the second is growth because 5/4 is greater than 1. Okay? So could be fraction, decimal. Suppose another example. Suppose y equal 0.8 x raised to the x, y equal 1.25 raised to the x. This is it's the same. It's exponential decay and exponential growth. Correct? Everyone follow me? No problema?
Yes, everything's fine.
Okay, everything is fine. So now let's move on to one topic, but inside the same exponential, no? But this is exponential equations. Exponential equation. Exponential equations. It's a typical question in the test. Exponential equation. Okay. And this is equation. This is an equation you need to solve, find the solution. But I anticipate that we have two kinds of exponential equation. The exponential equation that I want to explain now is relatively easy because we can manipulate in the way I want to explain now. So I call easy and complicated. Complicated is impossible doing the way I want to explain now, but I discovered another tools to solve the complicated exponential equation. But it's important that you realize that it's easy or complicated. How you know that? Well, okay. What's the idea? The idea, example 1, to understand this. Suppose that we have this equation, que is 2, 3 minus x is exponent equal 8. Okay, guys. Typical mistake I saw every day. I don't know why the students don't understand very well that this is exponent. Right? This is exponent. And the student believe that it's equivalent to say like that and apply this trivial property. This is wrong. Totally wrong, okay? Exponential. Now, in this case, it's easy for solving because 2 and 8, we can express it using the common base. Bueno, 2 es 2. 2 es 2. And 8 is 2 to the third power, correct? In the second line, you copy 2, 3 minus x equal 2 to the third power. Wow. In this moment, if you have two exponential equal each other, and the base is the same, then the fantastic conclusion is the expression in the exponent is the same. It's how you eliminate mentally these two. These two doesn't work. I don't want that you are doing like that. Bam, bam. This is no good. It's not good because you can do that when it's subtraction, division, maybe. But in the exponential, no. To say now, the idea behind this is, see, the exponential is one-to-one function, and the y is the same. It's because the x is the same, right? In particular example, see, we have two exponential, and the base I create artificially is the same. Therefore, the exponent is the same, and you forgot the base. Now you're solving this elementary kindergarten equation, it's obvious that x is 0. Boom, final answer. Yes or no? Do you understand the idea?
Yes.
Yes.
So I want to complicate a little bit, not too much because it's easy. I want to use, for example, exponent fraction or exponent negative or whatever, right? Let's see several examples. And you let me know so you understand it. Suppose the exponent is 2x plus 1 equal 25. Okay, again, this is the same similar idea in which you can, so you copy here in the corner, you can 5. And 25 is 5 squared. Okay, so I can express it both sides, right, left and right, using the common base. Oh, again, happen if you have two exponential and the base is the same, then 2x plus 1 equal 2. And this is the way I like to represent this. You don't need to do in that way. It's like me. So the thing I don't want to see, can you delete this? This is not good. But another way to represent this idea is, suppose you have 5, 2x plus 1 equal 5 squared. Now, this implies that 2x plus 1 is equal to. Okay? And everyone understand very well. This is similar to this. This is more, you know, symbolic using the terminology of the logic if then. But it's okay. Now you focus on this elementary kindergarten linear equation. 2x is equal to minus 1. 2x equal 1 divided by 2 x is 1/2. Is the answer. I remember domain of the exponential is all real number, therefore always you have solutions. Not necessarily one, maybe si es quadratic equation and the exponent, but no, it's possible. But the thing I want to explain is that we have always solution. One always knows si the other side is negative, no. Okay, because domain of the exponential function is all real number. So never we have, for example, extraneous solution. Okay, solution case doesn't work. So example 3 now. Suppose 27 raised to the 4x. I say again, this is exponent, guy. You want to emphasize against exponent, you put a parenthesis. Equal 9 raised to the x plus 2. Exponential equation. What do you think about the common base? What is the common base in this example? What is the common base? What number is the common base? What is 9? Well, 9 is 9, I agree with you, but how you express 27 using 9 to the what is exponent?
You could use 3.
A3. I agree with you, mister. A3. Because 9 is 3 to the second power, and 27 is 3 to the third power. And you replace, no 27 anymore, it's 3 to the QE, raised to the 4x, is equal 3 to the second square, raised to the x plus 2. And remember, you apply one more time the exponent rule. Okay, when you have different level of the exponent, suppose you have something, x to the second to the third. What is the answer? Well, it's x to the 6. You multiply the exponent, right? In this case, you multiply 3 to the 12x is equal 3 to the 2 times parentheses x plus 2, because we have binomial expression.
I
No?
have a question.
Go ahead.
Why is it 2 parentheses x plus 2 and not 2x plus 4?
Because in this moment is a moment in which you apply this idea. Look, you continue on. It says 12x, and you distribute it here. Or not necessarily. Okay, it's 2x plus 4. Do you understand now?
Yes, I understand.
Okay. Actually, I don't do it that way. I continue working. Look. My opinion, well, it doesn't matter. This is the beauty of the mathematics. A different way, can you manipulate? You are doing well. You have no problem. This case means without distributive property, you suppose if two exponential and the same base, it's because the exponent is the same. So 12x is equal to parentheses x plus 2. And now I make a decision to apply distributive property. 2x plus 4. Now, well, 2x minus 2x, 12x, sorry, minus 2x equal 4. 10x equal 4 divided by 10, both sides. X alone, let me continue here, is 4 over 10 gets 2/5. When you reduce in lower term. Boom. Final answer. Any question? Example 3. In example 3, I complicate a little bit more because, well, we have 27 and 9, so you need to understand that the common base is 3. Okay. Clear or no? Example 4. Example 4 now. In the example 4, we have that idea. Square root 3 raised to the x plus 4. Wow, what the hell? Is equal 3 to x. The same challenge. What is the common base in this example? Opinion. You can do that. Come on. It's no big deal. It's doable for you. It's confusing square root 3 for you or no? Square root 3 is 3 to the 1/2 power. Yes or no? Do you remember that? How we use a fraction exponent to replace the radical? Yes or no? Answer.
Yes.
Okay.
No.
No, you don't remember. You said you don't remember. No, I explain. No? You
No,
don't.
I just don't know why you change it to a half.
Because remember the strategy is express both sides using the common base. Look. So you are doing this. You have, instead of square root 3, you copy 3 to the 1/2 raised to the x plus 4 and 3 is 3. 3 is 3. 3 to the x. Wow. Then, in that moment, if you have two exponential and the base is the same, do you see it's the same? Well, no, you see not clear now. You, for example, you apply the rule of the exponent multiplication, this and this. There's 3, 1/2, parenthesis, x plus 4. I put the parenthesis, guys, because this is a binomial, no? Entonces, 1/2 multiply whole thing. And the super fantastic way to indicate this idea is put the parentheses. And then, in this moment, if we have two exponential and the base is the same, my fantastic conclusion is 1/2 parenthesis x plus 4 equal x. Do you see the idea?
I understand now.
Well, I focus in this elementary equation, linear equation. So you don't like the fraction, no problema. You multiply the entire equation by 2. And you eliminate the fraction. 2 times 1/2 is 1, so x plus 4 equal to x. Guys, this is one way to do. If you want, you continue using fraction if you want, but it's okay. Or let's do it both ways. Now 4 stay here. 2x minus x. Well, it's x. Entonces, x equals 4. Boom. Another student can prefer the fractions. Well, okay, you apply distributive property directly here. We have 1/2 x plus something is 1/2 times 4 is 2. Okay, now 1/2 x minus x, and move this to the other side equal minus 2. And we combine later. Is, least common denominator is 2. We have x minus 2x equal minus 2. Okay, this is minus x over 2 equal minus 2. Wow. And now why not multiply or cross multiply? Either way, cross multiply. Minus x is equal minus 4 divided by -1 both sides. X equal 4. I suppose it's more complicated, no? It's a good idea always in algebra. When you have a fraction, you clear the fraction. How? Multiply by the LCD. Or no LCD, the only number that we have in the denominator is 2. And magically happens that the fraction disappears. And our equation is equivalent, but it's easier. Okay. I have 3 more examples. Suppose this example. Example number, this was number 4, no? Oh, let me see. Number 4, yeah. Now number 5. I I promise in the review packet we go over again to the exponential equation. Easy exponential and complicated. 2, 1 minus 2x. This is exponent, guys. When you see it's a small expression and the top, it's because it's exponent. If you want to emphasize it's exponent, you put a parenthesis. Equal 8 raised to the x plus 1. This is my new example. Again, my question is, what is the common base in this example?
2.
Excellent. She said it's 2. The common base is 2. Is 2. Okay, entonces 2 stay raised to the 1 minus 2x. I know que 8 is 2 to the third power, no? So you replace no 8 anymore, it's 2 to the cubic power, x plus 1. Okay, one more time. I apply the rule of the exponent, different level of the exponent you multiply. Entonces 2, 1 minus 2x equal 2, 3 times parentheses x plus 1. Do you see? Okay, I take care, when you multiply this and this, you put without parentheses. This is crazy, because I suppose que 3 multiply only x. No, 3 multiply whole thing. So you indicate using parentheses. Okay, one more time. If you have two exponential and the base is the same, I create artificially, then the exponent is the same. 1 minus 2x equal 3 times x plus 1. Ready for solving linear equation. Distributed. 3x plus 3. I try to do something in order to solve for x. Suppose that I make a decision that 3x stay here and I move 2x to the right hand side, okay, and 1 stay here and I move 3 to the other side. It's a negative 2 and it's a 5. Divide by 5, both sides. X is equal to minus 2 over 5, 2/5. And don't worry for this answer, que positive or negative, because the domain of the exponential function is all real numbers. So it doesn't matter if the answer is positive or negative or 0. It's perfect legal, that one. Everyone follow me in the example 5?
Yes.
Okay. So now example 6, I need help because it's a little bit confusing. Example 6 is 2/3. Oh, it's a fraction. Wow. Raised to the x power is equal 9 over 4 raised to the nothing. O sea, no necessary parenthesis then. 9 over 4. Wow. What should I do? What do you suppose that? Give me a hint. Do you see some relationship between the coefficients? 2, 4, 9, 3? Oh no. Opinion, guy. Answer me. Don't be shy. Come on. It's easy. Bueno, easy no, but try. If you make a mistake, no problema. You are a student now. Go ahead.
I was gonna say multiply it to make both the denominators 12.
No. Totally wrong. Okay, this is exponential. The exponential is different procedure. Okay, because look, suppose this is 2 to the x over 3 to the x. 9 over 4. What is the least common denominator in that case? And between 3 to the x and 4. It's 12. No. Definitely no. Right? Do you see? Do you see?
Yeah, I see.
Ah, this is not the right way. We need to create another way. Okay, let me pushing you to the idea. Look, what about 9? 9 is 3 to the second power, correct? And somehow I stay connection between this 9 and this 3. Somehow. Likewise, 4 is 2 to the second power, correct? Entonces I rewrite, bring down 2/3 raised to the x power equal 3 squared and 2 squared. Well, it look like similar, but no, not exactly the same. Repeat the question. What should I do? What should I do now? I'm doing the right way or I'm doing the wrong way? No idea, guys? Totally lost? Okay, I propose you one idea. You copy 3/2 squared. It's correct? I did well or no? Because it's the same exponent, no? Entonces, you know the property. Okay, when you raise to any power a fraction, it's equivalent to say you raise the numerator and denominator. It's okay?
Yeah.
That's so far. Entonces, almost we finish. Almost we finish. We have 2/3 raised to the x power, and we have 3/2 raised to the second power. Okay, we are doing, we guarantee the base is the same or no? Is the same or no? The same base?
No.
No, but what is the relationship between the same? You see something familiar? Express it in English. In English.
They're flipped.
Exactly. Exactly. They flip. What do you want to flip? The left-hand side or the right-hand side, mister? Do you understand the idea? He said get flipped. You flipped one fraction, you get exactly the same. And you flip either. I asked to him, what do you propose me? But he's quiet. Don't ask me, don't answer nothing. I suppose I flip the right hand side. Does this stay the same as always? It doesn't matter, guys. There are different ways to solve it. I flip that. 2/3. Yes or no? And what happened with the exponent? Stay the same or change? This is important. This is important in this chapter to understand the meaning of negative exponent, right? When you working with the negative exponent is reciprocal, flip. This is -2. Do you see this or no? Okay, this is easy, but it's conceptually deep. Okay, do you understand this or no? Come on, guy, answer me. That is a reason I don't like the lecture online, no? Because the student is quiet.
Did you
do
it by the reciprocal? That's how you got -2?
Exactly. This is the action. When you change the exponent from 2 to -2, the base, you flip it. Make sense or no?
Yes.
Yes.
Therefore, if you have in that moment two exponential and the base is the same, the conclusion is the exponent professor is the same. The answer is -2, and I finish my problem. Boom. Got it?
Yes.
Okay,
Yes.
one more and that's it. One more and that's it of the exponential, no? We continue another topic, no? Example 7, no? Yes, 7. Example 7 say 32 raised to the x plus 2. This x plus 2 is exponent. We continue doing exponential equation. 16, 2 minus x. 2 minus x. Solving this equation. Okay, the same question. What is the common base in this problem? Wow, it's a challenge.
4.
4. Well, 4 maybe yes, because let me see. 16 we can express it like a 4 square, correct? But 32 no. 32 no. 32 is 2 times 16, I guess so, no? Or 32, okay. Well, one efficiency way to realize this is you take 32 and 16, and you are doing the prime factorization. 2 16, 2 8, 2 4, 2 2. And 16, well, 16 is this part. Is divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. And so you select 4 like a common base, maybe you can, because 16 is 4 and 4. But 32 no, 32 have no 4. Well, yes, 4 and 8 maybe.
8 and 4, yeah.
8 and 4, But okay, I agree with you, 8 and 4. Okay, 4 we have. Okay, the base can you select. Good for you. How you spread 8 using 4 base? Well, it's 2 times 4, no? You see that always we have a problem of the one extra 2. So I do not guarantee to have the same base in both sides if you select 4. Yes or no?
So 2 would be better?
Exactly. 2 will be better. So you see, okay, 16. Well, actually, 16 is 1, 2, 3, 4. And 32 is 1, 2, 3, 4, and 5. Okay, so my opinion, 16 is 2 to the 4th power, and 32 is 2 to the 5th power. And the common base is 2. You replace 2 to the 5th power raised to the x plus 2 is equal 2 to the 4th power, que is equivalent to 16 raised to the 2 minus 6. Okay, now apply the rule of the exponent. Multiplication 2, 5 parenthesis x plus 2 equal 2, 4 parenthesis 2 minus 6. Okay, ready. If you have two exponential and the base is the same, I don't care the base, the answer is just the exponent equal each other. Okay, now we focus on the solution of this elementary linear equation, similar to the middle school. 5x plus 10. Distribute a minus 4x. 5x plus 4x equal a minus 10. Minus 10. This is 9. This is negative 2. Divided by 9. X is equal to negative 2 over 9. Negative 2 over 9. Get the answer. Any question, guys? Super good. No, one more. I have another example. Yes. It's A example I bring today. So no problema, everyone follow me? Don't worry, guys. This is the introduction. In the review packet, we go over again to this, no? In detail. Example A, no? A, yeah. And you help me example A, because I suppose that you You understand, you learn a little bit this idea for the exponential equation. Example A, no, is, look, wow, it's a cubic root of 5 raised to the minus x. Wow, what the hell? Look, I complicate a lot of this. Root, negative exponent, and 1/5 raised to the x plus 2. Wow, this is my new, by the way, it's the last one. This kind of question. Again, what do you believe que este common base? In that case. How do you believe que es common base?
Put 5 to 1/2.
To 1/2 or to 1/3? Because it's cube.
1/3.
1/3. Cubic root of 5. She said que 5 raised to the 1/3. Is it correct? And what about the, this is the left hand side. What about the right hand side? 1/5. But what the hell is that? How you express 1/5 using base 5? What exponent here?
Would it be negative?
Negative what? Negative 1 or negative 2 or negative 3 or negative 4?
-1.
-1. So when you raise 5 to the -1 is 1/5. Okay? So you raise 5 to the -2 is 1/5 squared, reciprocal. The action for the negative exponent is reciprocal. And you put in the bottom the 2 or 1 or whatever, no? In this case 1, it's easy, entonces 1/5. Super good. So we express both sides using common base, que by the way is 5, no? Is 5 raised to the 1/3. Another parenthesis, minus x equal 5 minus 1, que es 1/5, x plus 2. Everyone follow me?
Yes.
Okay, now the rule of the multiplication of the exponent is 1/3 x negative. Bang, here. Equal 5 -1. You know, -1 is invisible. X plus 2. Make sense? If you want, you put -1 here. But no, it's not necessary. I don't like. Because if two exponential and the base is the same, then the exponent I taking 1/3 x equal minus parenthesis x plus 2. And we focus in this equation. What should I do? Help me. What should I do? What should I do? Because I want to eliminate two things. I want to eliminate negative signs, too many negative. I don't like this. And why not eliminate the fraction? No? You can. Or the student can prefer working with the fraction. It's okay. I respect. But what should I do? What should I do for eliminate both in one chop?
Multiply by 3.
By 3 or by -3, mister? Miss.
-3.
Yeah, much better. Yeah. Multiplication, the whole equation by -3. Multiplication by -3. Because we're doing two actions, a negative times negative, positive, and 1/3 times 3 is x alone. And this is 3 times positive, of course, x plus 2. Make sense? Because negative times negative is positive. Positive what? Positive 3. Now I apply this distributive property. X is equal to 3x plus 6. X minus 3x equals 6. Combine is minus 2x equals 6 divided by negative 2 both sides. X is minus 3. End the story. Boom. Final answer. Beautiful. Any question? So I try to cover different possibilities. I try to cover square root, cubic root, negative exponent. You need to be familiar. Negative exponent is reciprocal. It doesn't matter if it's negative 1 or negative 2 or negative 3. Si es 5 to the minus 1, es 1/5. Si es 5 to the minus 2, es 1 over 5 squared, que es 25. 1 over 25. And so on, right? Si es 5 to the minus 3, es 1 over 5 to the cubic, que es 125. And so, do you understand very well? Negative exponent, fraction exponent. Okay. May I erase the board? Yes or no? Okay. Okay, I put it one example. Wow. Tricky, tricky, tricky. Okay, nobody can solve it. Therefore, suppose you have this elementary. Look like elementary, however, it's complicated. 2 to the x equals 3. This is the classical example that we cannot solve it using the traditional approach that we are doing so far. Because 3, we never can express like a base of 2. Never. Entonces, in this example, this is a complicated exponential equation. Okay, in the test we have complicated and easy. And the only possibility for solving this is using one thing I want to study now, que es the logarithmic function. Okay, so expanding this equation, I suppose that when you understand very well logarithmic function, I promise that the first example that we're doing is this. So now logarithmic function. New topic. Okay, definition. As always, when you study new function, you define definition. The definition of logarithmic function is it is the inverse function of the exponential. It is the inverse function of exponential. Exponential we studied in detail today at the beginning. Now I discovered that exponential is 1-to-1, therefore it's invertible. Si es invertible, entonces we have inverse, and this inverse is the logarithmic function associated with this. So let me clarify this idea. Suppose that we have the famous f of x. Recall this idea. F of x equal a to the x. And my goal now is find the inverse. Find the inverse. Remember to find the inverse in the first topic of this chapter, we study in detail find the inverse. You replace f of x for y. And now this is an important moment. You interchange x and y. This is important. Now x is equal a to the y. Something like that. Wow. And this is inverse, professor? Yes, but in implicit form. If you want an explicit form, que es the proper way, Well, you do something in order to solve y. So y alone is equal now. And so you use a new notation that you need to be familiar. Is the name of the function que es logarithmic log is a name of the function. And this notation have one small number here, que es a, que es the base, and we have x, que is the argument. Boom. And this is the way that we are using explicit form. But I want to explain in detail the meaning of that because it's confusing so far. Okay, what means logarithmic function? Okay, so now to explain that, we have this idea. I split interpretation of the logarithm. We focus in the logarithmic interpretation. To understand the logarithmic, well, I propose you, for example, right here, exponential statement. Yeah, I suppose I understand very well any statement expressing exponential, and here logarithmic statement. Okay, it's two different ways to express the same idea, and this is fantastic because sometimes happen not now, but when in the complicated problems that we are doing, of course, in this chapter, I promise, complicated. Sometimes happen okay, you have a logarithmic statement and you are stuck. I don't know how solving that problem, and you change to exponential. So this is perfectly interchangeable. Like you convert exponential to logarithmic or logarithmic to exponential. Let me explain in detail one couple of the examples, and after I explain several until you understand very well the interpretation. Suppose 2 to the 5th power is 32. This is before this idea. This is exponential statement. The base is 2, the exponent is 5, and the result or answer is 32. How you translate this statement in the new language of the logarithmic? Well, okay, you put the famous log word, and the base is 2. You put a small 2 here, open the parenthesis because this looks like a function notation, f of x. Okay, f is the name of the function. In this case, the name of this special function we studied today is log, logarithmic. And you put inside the argument is 32 and the answer is 5. Wow, what is the interpretation, professor? The interpretation is the answer. The answer of the logarithm is what exponent is necessary to raise the base case 2 in order to get 32. So the answer for the logarithm is always the exponent. Okay? It's completed backward. In the exponential, no. In the exponential, you have the base and the exponent, and you get result. In the logarithm, no. We have the base, yes. We have the hypothetical result. I need to find what the exponent is necessary to raise the base in order to get 32. One more example. 3 to the 4th power is equal to 81. It's easy because 81 I know, que es 9 times 9. Okay, 9 times 9. Y I know que 9 is 33. Entonces, actually, you have 4, 3, and multiplication is 81. No problem. It's clear. However, when you translate this exponential statement to logarithmic statement, you put the word log. It's obvious that the base is 3 in this, because this number is the same. It's perfectly the same number. So the small number that you copy here, is the base of the hypothetical exponential where it comes from. Okay? Entonces the answer here is 81. And what is the exponent necessary to raise 3 in order to get 81? 4 is the answer for the logarithm. Do you understand the idea or no? Confusing? Repeat again. Clear or no? Confusing?
Yes, it's clear.
It's clear. Okay, okay. I want to verify if it's clear. Now, I bring one couple of the example, and the rest you help me to investigate. Suppose. This is totally out there. This. Es super easy when the logarithm is base 10. For example, logarithm base 10 of 100. What do you think? Okay, my thought is, wow, what exponent? What is the exponent que es necesario to raise 10, que es the base, in order to get 100? Intuition, no mathematics, intuition. What is the exponent que es necesario to raise 10 in order to get 100?
2.
2 is the answer. Do you see or no? Okay. Another approach, no intuition, a little bit more strong, is you don't know. You put x and you interchange this statement que es logarithmic to exponential. Entonces I ask, bueno, what is the base? What is the base? The base is 10. The exponent is exactly I am looking for, que she said que es 2. Okay, I agree with her. Equal 100. Okay, I change logarithmic to exponential. Do you understand this changing? And I know that 100 is 10 squared. Wow, in this moment I have 2 exponential and the base is the same, therefore the answer is 2. Super good?
Yep.
Super good? Who helped me with the next? Logarithm base 10, it's easy to understand. 1000. What are the answer?
It'd be 3. Power 3.
It's 3. He is smart because count how many zeros we have in the problem. We have 1, 2, and we have 3. 1, 2, 3. It's 3. The answer is 3 by the same reason. No? You can prove again if you want. No? And what about that million? 1, 2, 3, 4, 5, 6. What is the answer? 1 million. Logarithm base 10. 6.
6.
Everyone follow me? It's clear?
Yes.
Okay, super. Now, logarithm now base 10 of 10. I want to complicate a little bit. What do you think?
Would it be 1?
Excellent. A1. But okay. Remember, intuition is important today. I promise that next time we are doing this using calculator. So everyone be aware that this chapter is impossible without calculator, okay? So calculator, scientific calculator que contain logarithmic, we need an exponential, no? We need from next lecture. She said que 1, okay. Suppose que I have no idea. And I convert to exponential. The base is 10. The exponent, no idea. The answer is 10. Wow, unbelievable. Of course, 1. Same exponential, same base, x equal 1. This situation happens always. And this is the important property. Logarithm of any base. And they are perfect coincident. This number and this number, the answer is 1. Keep in mind this. O sea, maybe it's confusing in that way, but for example, logarithm base 2 of 2 is 1. Logarithm base 3 of 3 is 1. Logarithm base something of something is 1. Make sense? Okay. Now, Let's continue with the base 10. It's easy to understand. Logarithm of base 10 of 1 is equal to something. Wow. I have no idea.
0.
0, very well. It's 0. It's 0 because 10, que es the base, raised to the 0 power, is equal to 1. Very well. And this is the universal point in the logarithmic function que we studied in a few minutes. 1, 0. Do you remember the universal in exponential que es 0,1? And you remember very well that the relationship between exponential and logarithm is interchange x and y. See, we have universal point in the exponential que es 0,1. It's obvious that we have another universal point in 1,0 for the logarithmic function. Very, very, very good. Very, very good. But I want to complicate a little bit your life. Logarithm base 10. We continue base 10, que es easy, of 0.1. What's the answer to that? It's possible, it's impossible, it's undefined. I have no idea. I promise que next lecture we are doing everything using calculator. I want to teach you how. Everyone bring the calculator for the next lecture, okay? But intuition. What about the logarithm base 10 of 0.1? Nobody? Nobody know? Nobody know?
Is it negative?
Pero negative what?
1.
Excellent, excellent, excellent. It's negative 1, miss. Let me prove. She using her intuition say que es negative 1. Suppose que I have no idea, totally lost. I convert to exponential. 10 is the base, x is the exponent, I have no idea, equal 0.1. Pero 0.1 is 1 over 10. And 1 over 10 is the reciprocal 10. Negative 1 exponent, therefore it's clear to exponential. Same base, x equal negative 1. Super good. And make sense because 0.1 is the reciprocal 10. And what about logarithm base 10 of 0.01? It's the same idea, intuition.
Negative 10.
Negative 10, no.
No.
Too much. No negative 10. Okay, no, I don't have idea. Okay, you don't worry, you relax. You put x. And you changing this statement logarithmic to exponential. The base is 10. The exponent is exactly the same. I need to find 0.01. Pero 0.01 is 10th, no? It's 1 over 100. Reciprocal 100, no? Yeah, this is 1 over 10 to the second power. This is 10 to the minus 2. Therefore, x is minus 2. Makes sense?
Yes.
Ah, nice. And what about logarithm base 10 of 0.001?
Negative 3.
Absolutely perfect. Intuition. Very well. Yeah, I promise que next lecture we are doing this by calculator. There are two different ways. I want you see both ways, calculator way or intuition way, or by hand. Sometimes it's possible, sometimes no. Sometimes only with the calculator. Entonces, let me try in that moment to say something. Okay, logarithmic of the positive number, but it's impossible. Look, logarithm base, any base, not necessarily 10 is example, of 0 of negative number, suppose negative 4, I put arbitrary, is completely undefined. I want to prove this. It's complete out of the domain. So logarithmic is the inverse function of the exponential. Y I suppose que you remember que in the exponential function domain is a real number. Domain. And range is parenthesis, no bracket, parenthesis 0, infinity. This is domain and range for the famous exponential that we study today. But logarithmic is inverse. It is inverse, we interchange domain and range. So for the logarithmic function, domain, range. Okay, domain is exactly the range. Is 0, infinity. This guy is this guy. And this guy is this guy. F or real. But the answer que offer logarithmic function is positive, negative. You see it's negative, negative. It's negative or positive, depending on the number, no? However, the logarithm cannot get inside the argument 0 or negative number. This is, you put in the calculator gets smart, understand very well, it's out the domain, and giving the display messages out the domain, undefined. Out the domain, out the domain is the messages. Well, depends on the calculator. Okay, let's practice a little bit more logarithmic. But we are doing backward. Suppose I give you the logarithm statement. And without calculator, using intuition, or no intuition, you know, conversion to exponential, you determine that value. Or intuition. Okay, you say, well, okay, the professor explained me, que the logarithm give me the exponent. So say, well, exponent of what? You raise 4 in order to get 64. What is the exponent? Can you raise 4 to the something power and give me 64, right? Somebody get the answer or no?
3.
3, very well. That's it, because 4 to the third power is 64. So 4 times 4 is 16, and 16 times 4 is 64. What about logarithmic base 5 of the 125?
Three again.
3 again, wow. Because 5 to the QE is 125, because 5 times 5 is 25, and 25 times 5 again is 125. Good, very good, very good. And what about logarithmic? I want to complicate your life now. Logarithmic base 5 again of 1 over 125. Wow. It's simpler, it's the same. It's illegal, it's undefined. It's possible, it's impossible. What changed when you flip it? This argument. No idea? This is the central idea of today. Interpretation logarithmic. It doesn't matter que it's a number or it's reciprocal. What is the idea behind reciprocal? Can you see before?
Is it negative 3?
Exactly, very well. It's a negative 3. Because we have two actions, no? We have the action 3. This is exactly the same of this, but it's a reciprocal. When you flip it that, okay, to say you You understand that property. Look, logarithm of the any base of the 1/8 is -1. Yes or no? The reciprocal is -1. Okay, forget about that. It's not important. Suppose que in one moment you don't understand very well. Okay, you put x and you change to a exponential statement. 5 to the x is equal 125. Done. I did that. I change from logarithmic statement to exponential statement. But in the previous example, I realized that this is a 5 cubic, no? And reciprocal is negative exponent. Wow. We have two exponential, same base, exponent is the same. In the story. Okay. One more tricky example. Logarithm 1/2, base 1/2 of 4. Wow, I don't understand. Professor, is possible logarithm of fraction? Yes, it's possible. Remember the base, you have two possibilities, no? When the base is greater than 1, and when the base is less than 0, or so greater than 0 and less than 1. So you have two possibilities. Never it's totally illegal negative base. You know that. Because the logarithm comes from for the exponential. -2, this is crazy. But we have two possibilities, no? The possibility that the base is a fraction here and between 0 and 1. Oh, no. It's a whole number, but no whole number, a real number. Because the base could be 4.5, logarithm of 4.5. Yes, why not? Yes, doesn't matter que es decimal or es irrational. Logaritmo radical 2, yeah, it's possible. It's crazy, no? Pero es possible. Entonces now, remember, base never is negative. In this case, the base is less than 1, and the argument is greater than 1. Well, I have no idea. Somebody have idea? What is the answer of this logarithm? Using intuition. Everyone is lost, no? Okay, no problem. I put x, I interchange or change to the exponential. The exponent is 1/2. The base, sorry, is 1/2. The exponent is x. And the answer is 4. Wow! So we have in that moment one super easy exponential equation. I suppose it's 2. It's 2 or -2. Well, no, I have no idea. What is the procedure? The procedure is find the common base. What is the common base? You say it's 2, no? Maybe. The common base?
2. Yeah.
2. I agree. And 1/2 is 2 to the -1, correct? And 4 is 2 to the second. Okay, nice. I like that. 2 to the -1 raised to the x is equal to 2 to the second power. Apply one more time. The multiplication for the exponent, 2 to the -x is equal to 2 to the second power. Entonces, if you have two exponential and the base is the same, que es 2, therefore the exponent is the same, que es -x equal to, therefore x is -2. Okay? Entonces, in this moment, I want to notice one idea. Look. If the number inside the argument is greater than 1 and the base is greater than 1, the answer is positive, logarithmic. This is similar. However, if the base is greater than 1 and the number in the argument is less than 1, the answer is negative. And the third scenario is the base is less than 1 and the argument is greater than 1, again, the answer is negative. Because the reason is clear. The reason is clear. In one moment, you need to flip it. And when you flip it, the answer is negative. Okay, entonces, the majority of the logarithm that we are using in our problem, the base is greater than 1. We have a standard that we study in one moment, but no now, in which the base is greater than 1. So the standard is the logarithm that we have in the calculator. But no, not today, not today. Today is the day to understand very well logarithmic idea, the interpretation. Do you understand this or no? Okay, repetition again, the idea. See the number and the argument, okay, the number inside the parentheses of the logarithm is greater than 1. And the base is also greater than 1. They are perfect matching, coincidence, a positive. However, see, do not matching, see the number less than the inside the argument is less than 1, and the base is greater than 1. So they are like a contradiction. And how you save that contradiction, negative answer. And here is similar but backward. The base is less than 1 and the argument is greater than 1. No matching, so you expect negative solution. Clear? Suppose logarithm of the 1/5 of the 1/25. Somebody have idea what is that? It's positive or it's negative? Okay. Understanding. The answer that I expect is positive or it's negative. Matching, doesn't matching, they are no idea, lost.
Would it be positive?
Positive, yeah, positive. But positive what? Do you get the answer or no? Okay, don't worry. I put X. Remember, always we save the problem, you put X. You are confusing. I don't understand so far very well logarithmic. However, I understand very well exponential. There are no reason to effort more with the logarithm statement. I'm switching to the exponential statement. The base is 1/5. The exponent is exactly I want to find, and it's a 1/25. Got it? And 1/25 is 1/5 square, right? So now, well, okay. And well, okay. Oh, much better. 1/5, 1/5 square, correct? Therefore, we have exponential here. We have another exponential, the same base. The answer is 2. But the most important I want to explain is if the number here is less than 1 and the base is less than 1, again, they are coincidence matching and the answer is positive 2 or positive number. Do you understand the idea that I want to convey, transmit to you? Okay?
Yes.
We have two possibilities. Logarithm will give me number positive or number negative. See, they are perfect matching. See, the base and the argument both are greater than 1. The answer is positive. See the base and the argument both are less than 1. The answer is also positive. However, see, there are discrepancies. See, the argument is less than 1 and the base is greater than 1, or opposite is negative. Okay. So now, Professor, I want to explain the graphic of the logarithmic. But in this case, I want to use Desmos to see more clear, Let me know if you see Desmos. So I want to explain now the graph of the logarithmic. I create for this job one script of Desmos. I want to share with you. Okay, there you go. Do you see decimals?
Yes.
Yes.
Okay, look. This is the classical exponential growth. In this case, I put the base 2. And this is a typical point. Look, in green color, universal 0,1, 1,2, and so on. And the blue color or purple color is the when there is negative, no? -1 is 1/2, -2. This is a classical exponential. Okay, now here we have the another exponential, que decay. Wow, you see it's completely symmetric. It's completely symmetric. Exponential growth, exponential decay. Well, you know that. You know that. Okay, now, no, this is not. This is another. Okay, no. All right, let me see. Okay, there you go. This is logarithmic. Logarithmic. Okay, logarithmic and exponential. Look. Let me show you right now. Boom. Okay. In this case, I'm using the same color. Blue color. So this is the exponential function. One. And this is logarithmic. And makes sense. Because the only thing I did was interchange x and y. This point is the famous 0,1. Now it's a point 1,0. 1,2 become 2,1. And so on, 2,4, 4,2. And the negative, guys, is instead of negative 1,5 is half comma -1. And you see, the important thing I want to illustrate now is looking the graph of the exponential. You see that the domain, the logarithmic, the domain of the logarithmic function is only the positive number, right? Never negative. We have no, let me delete exponential, no exponential anymore. We focus in the logarithmic. This is the logarithmic graphic, and you see que es asymptotically. In this case, we have no horizontal asymptote. We have vertical asymptote at x equals 0. That the curve approaches but never touch the asymptote. The vertical. In the exponential, we have horizontal. In the logarithmic, we have vertical asymptote. So now, to do by hand, the graph of the logarithm is easy because we have the universal point, is 1,0. And for example, you have the point here is 2,1 because the base is 2. So this logarithm is base 2, guys. Okay? And logarithm base 2 of 2 is 1. And logarithm 1/2 of base 2 of 1/2 is -1 because it's the reciprocal. Well, similar idea happen when your base is 0.5. Look at that. What the hell? Look, it's a logarithm when the base is 1/2. And we compare with the exponential when the base is also 1/2. Do you see it's also symmetric with the line y equal x, right? Let me show you. Let me delete the exponential. No exponential anymore. No. We're passing through the same point, is 1,0. Both exponential. Look, logarithmic. Sorry, the logarithmic base 2 is the blue. Logarithmic base 1/2 is the purple curve. But passing through the same point, is 1,0, universal point. Now, in this case, logarithm of 0.5 is 1. Logarithm of 2, base 1/2 is -1. Okay, the important is to be familiar with the graph. They are inverse function each other, exponential and logarithmic. Okay, and is symmetric with respect to the line y equals x. Exactly, we predict at the beginning. And the exponential asymptote and the horizontal asymptote, and the exponential become like a vertical asymptote in the logarithmic. Okay, let's do it quickly. Let's go back to the board. Remember, today is the day to the intuition, to get the idea about the logarithmic. Now, next lecture, we're working with the logarithmic in detail. Okay, erase. Do you see the whiteboard?
Yes.
Suppose in the test, you say, well, professor, I want to do the graph of that logarithm. Logarithm base 2 of x. Graph. Okay, it's doing. Do it by hand. I don't know. Remember, my goal is always doing in decimal, no? But to get more clear idea, let's do it by hand. Okay. So now, I select 2 because 2 is easy, no? Give me no too big number, because out this paper, because it's short paper. Remember, to do the graph of this, we need the universal point, is this, 1,0. Any logarithm passing through that point. Because logarithm base 2 of 1 is 0. You know that fact. This is a property, it's important. Now what about logarithm base 2 of 2? Tell me.
1.
No, 1. So the point is the point 2,1, no? 2,1 here. Yes? Because this is the x value and this is the y value, correct? And what about logarithm base 2 of 4?
Two.
2. So the point is 4,2. And what about logarithm base 2 of 8? I intentionally put here number get power of 2. 2, 4, 8, 16, 32. So you put another number 7, this is decimal, or ugly decimal. Okay, the only possibility is you cannot do by hand, you know, calculate. This is 3. But unfortunately, this x and this paper is stopped in 6. So I suppose 7, 8 here, approximately 3. Because at least that part look like that. But I want to continue. For example, logarithm base 2 of 1/2. What is the answer of this? Again, what happened with the reciprocal? You don't understand very well reciprocal?
It's negative.
It's negative what? It's negative. I agree with negative. I agree. But negative what? Negative 1,000?
Negative 2.
Negative 1.
Negative
1. Let me explain one more time. Look. It's negative 1. Look. Suppose that you have no idea. Guys, convert this statement to exponential. 2 is the base. X is the thing I don't know, equal 1/2. And 1/2 is 2 to the minus 1, reciprocal. Negative exponent, reciprocal. Therefore, x is negative 1/2. And the point is the point 1/2, comma, negative 1. Get here, look. 1/2, negative 1. Here. And likewise, 1/4 is negative 2. And 1/8 is negative 3. So the part of the continuation, I don't know why I put in different color, but I put in different color because this is the positive bar and this is the negative bar, but it's the same curve. This is the curve corresponding with the logarithm base 2 of x. And super important part, you don't forget never the vertical asymptote. at vertical asymptote at x equals 0. Okay, coincident with the y-axis. Okay, guys, stop here. Stop for a moment. And so everyone, please bring the calculator. Next lecture. Well, another recommendation, please. Help me to do well. Let me stop.